Everything you know about where we came from is wrong. And I can prove it with a single number, 27 million square kilometers. That's how much land vanished underwater between 15,000 and 6,000 years ago. Land where people lived, land where they built, land we've never searched. Right now, you're sitting on the edge of one of the biggest mysteries in human history, and most people don't even know it exists. Because here's the thing about archaeology, we've been looking in all the wrong places. The cities we found, the monuments we study, the civilizations we call the first, they might all be refugees, survivors, the ones who fled to higher ground while the real story drowned beneath 40 meters of seawater. And what I'm about to show you isn't some fantasy about Atlantis or ancient aliens. This is hard science, peer-reviewed research, and it's terrifying. Let me ask you something. When you think about ancient history, what comes to mind? Egypt, Mesopotamia, maybe the Indus Valley. All of these civilizations emerged around 5,000 to 6,000 years ago. Before that, we're told humans were simple hunter-gatherers, wandering in small bands, barely scraping by with stone tools. The story goes like this. Humans existed for 300,000 years doing basically nothing, and then suddenly, boom, in the last 5,000 years we invented everything. Writing, cities, agriculture, mathematics, monumental architecture. All of it in a geological blink of an eye. Does that make sense to you? Because it shouldn't. And for decades, archaeologists have been quietly uncomfortable with this timeline, but they couldn't explain the gap until now. The problem isn't that humans weren't capable before 5,000 years ago. The problem is that we've been studying history through a keyhole. We've only been looking at the land that's still above water, and that land represents less than 1% of where humans actually lived during the Ice Age. Think about where humans naturally settle. We cluster on coastlines. We build cities near rivers, estuaries, harbors. We fish, we trade, we develop maritime cultures. Even today, over 40% of the global population lives within 100 kilometers of a coast. It's prime real estate access to food, transportation, trade routes. During the last ice age, sea levels were 120 meters lower than today. The coastlines weren't where they are now. They were way out there on what we now call the continental shelf. And then the ice melted. Over the course of 9,000 years, the ocean rose and rose and rose, swallowing everything. Doggerland, a massive landmass connecting Britain to Europe, home to thousands of people for millennia gone, buried under the North Sea. Sunderland, an area the size of India that connected Southeast Asian islands, completely submerged. The Persian Gulf was a river valley. The Black Sea expanded catastrophically. Coastal settlements all around the world drowned. 27 million square kilometers. To put that in perspective, that's larger than the entire continent of North America. An entire continent's worth of land where humans lived and built and created, and we've barely looked at any of it. Less than 0.05% of the submerged continental shelves have been systematically surveyed for archaeology. So here's the challenge. How do we write the history of humanity when most of the places where humans lived are now underwater? How do we know what we're missing? And more importantly, what if the civilizations we do know about, the ones that appeared suddenly after the ice melted, weren't starting from scratch? What if they were rebuilding? Let me take you back to southeastern Turkey, to a barren hillside that looks like it shouldn't matter. Dry, rocky, nothing growing there. Shepherds grazed their flocks on this hill for centuries without realizing what was underneath. Then in 1994, a German archaeologist named Klaus Schmidt started digging. And what he found shattered everything we thought we knew about prehistoric humans. Göbekli Tepe. The name means Potbelly Hill in Turkish. Doesn't sound impressive, but what's buried there is possibly the most important archaeological discovery of the last 100 years. Because Göbekli Tepe is a temple complex with massive stone pillars arranged in circles, some of them weighing 10 to 20 tons, carved with intricate reliefs of animals, foxes, snakes, birds, wild boars. The pillars stand up to 6 meters tall. The stonework is precise. The artistic skill is extraordinary. And it was built 11,600 years ago. That's 7,000 years before Stonehenge. 7,000 years before the pyramids of Giza. This was built before humans had pottery, before they had metal tools, before they had agriculture. According to everything we thought we knew, the people who built Göbekli Tepe should have been small bands of nomadic hunter-gatherers, struggling to survive, with no time or resources for monumental construction. But here's what the evidence actually shows. To quarry these stones, transport them up to a kilometer from the quarry site, erect them in precise geometric patterns, and carve them with such detail would have required hundreds of workers. Not just for a day or a week, this would have taken years, possibly decades. Where did these workers come from? How were they fed? Who organized them? This requires social complexity that wasn't supposed to exist yet. The excavators found something else interesting. Göbekli Tepe wasn't a settlement. There are no houses, no hearths, no signs of permanent occupation. It was purely ceremonial, which means people were traveling from somewhere else to build it and use it. They had homes somewhere. They had a base of operations. And wherever that was, it was sophisticated enough to support large-scale construction projects. Now I want you to think about the geography here. Göbekli Tepe sits in the hills, inland, in a relatively harsh environment. Why would hunter-gatherers build their most important ceremonial center in the middle of nowhere? One possibility: they didn't. Maybe this wasn't the center. Maybe this was the refuge. Because here's what else happened 11,600 years ago. The world was going through one of the most violent climate changes in human history. It's called the Younger Dryas period, and we need to talk about it because it's the key to understanding everything that comes after. Younger Dryas, The catastrophe. Picture this. For about 2,000 years, starting around 14,700 years ago, the Earth had been warming up. The ice sheets were melting, sea levels were rising, but it was a gradual process. Life was actually pretty good. Temperatures were mild. Rainfall was regular. Ecosystems were flourishing. Humans were thriving in this stable, warm period called the Ballingallorod Interstadial. Then, 12,900 years ago, something happened. And within decades, not centuries, decades, the global temperature plummeted. In Greenland, ice core data shows temperatures dropped by 5 to 10 degrees Celsius in less than a human lifetime. That's catastrophic. Glaciers that had been retreating suddenly surged forward again. Forests died. Lakes dried up or froze. The warming trend reversed so fast that the planet was thrown back into near-ice age conditions. This cold snap lasted 1,200 years. We call it the Younger Dryas, and it was brutal. Across North America, 35 genera of large mammals went extinct. Mammoths, mastodons, giant ground sloths, saber-toothed cats gone. In the Near East, wild grain stands that humans had been harvesting for millennia shrank dramatically. Across Europe, archaeological sites show a sudden drop in population. People were dying or fleeing. For decades, scientists debated what caused this sudden freeze. The mainstream explanation involved changes in ocean circulation. Melting ice sheets released massive amounts of fresh water into the North Atlantic, disrupting the Gulf Stream and shutting down heat distribution. That's a solid theory, and there's good evidence for it. But there's another theory, one that's more controversial but increasingly backed by physical evidence, and it involves the sky falling. In 2007, a group of researchers proposed something called the Younger Dryas Impact Hypothesis. They suggested that around 12,800 years ago, fragments of a comet or asteroid exploded in Earth's atmosphere over North America and possibly Western Europe. Not a single massive impact like the one that killed the dinosaurs, but an airburst event, multiple explosions in the atmosphere that generated incredible heat and sent shockwaves across the continent. When this was first proposed, a lot of scientists were skeptical. Extraordinary claims require extraordinary evidence, and the evidence seemed thin. But over the last 15 years, the data has been piling up, and it's getting harder to ignore. In 2020, a team studying the archaeological site of Abu Hurira in Syria published their findings. Abu Hurira is significant because it shows the transition from foraging to early agriculture. People lived there for thousands of years. And in the layer of sediment dated to exactly 12,800 years ago, researchers found something shocking: meltglass. Meltglass is what happens when silica-rich materials are exposed to temperatures above 2,200 degrees Celsius, hot enough to melt sand and rock. Natural wildfires can't produce that kind of heat. The hottest wood fire might reach 800 degrees. To create meltglass, you need something extreme, like an airburst from a cosmic impact. The thermal radiation from such an event would incinerate everything in its path within seconds. They also found nanodiamonds. These are microscopic diamonds that form under the intense shock pressure of an impact. You don't get nanodiamonds from normal geological processes, and they found them in layers dated to the Younger Dryas boundary at over 50 sites across North America, Europe, and the Near East. Then there's the platinum anomaly. Platinum is rare in Earth's crust, but abundant in asteroids and comets. In Greenland ice cores dated to 12,800 years ago, scientists found a massive spike in platinum concentration. The spike is global and synchronous. It shows up at sites across multiple continents at exactly the same time. In North America, there's a layer called the black mat, a dark, carbon-rich layer of soil found at hundreds of sites across the continent. Below the black mat, you find fossils of megafauna and evidence of Clovis people, one of the earliest cultures in the Americas. Above the black mat, the megafauna are gone. The Clovis culture disappears. The tool technology changes completely. The black mat represents a massive burning event, consistent with continent-scale wildfires triggered by airbursts. Now, I'm not saying this hypothesis is proven beyond all doubt. Science doesn't work that way. There are still scientists who dispute these findings, who argue the evidence can be explained by other means. But the data is getting stronger. What we can say with confidence is this: something catastrophic happened 12,800 years ago. The climate shifted violently. Ecosystems collapsed. Entire populations were wiped out or displaced. And if there were complex human societies living on the coastal plains during the Ballingallorod warm period societies, we know nothing about because their homes are now underwater. The Younger Dryas would have destroyed them. The DROWNED, HEARTLANDS, second major section. This is where the story gets really interesting. Because while the Younger Dryas was a disaster, it wasn't the only disaster. In fact, there was a second catastrophe waiting at the end of it. Around 11,700 years ago, the Younger Dryas ended as suddenly as it began. Temperatures shot back up. The ice started melting again. And this time, the melting was rapid. Massive ice sheets covering North America and Northern Europe collapsed, releasing unimaginable volumes of water into the oceans. We can track this process through something called meltwater pulse 1b. Between approximately 11,400 and 11,000 years ago, global sea levels rose by about 15 to 25 meters. That might not sound like much, but remember, coastlines are generally flat. A 1-meter rise in sea level can push the shoreline inland by 100 meters or more. A 20-meter rise, that can drown entire landscapes. And the flooding didn't happen slowly. In some areas, sea levels rose several meters per century. That's fast enough that within a single human lifetime, the world you knew as a child would be unrecognizable. Villages that sat a kilometer from the shore would be underwater. River valleys would become bays. Hills would become islands. Let me make this concrete by telling you about Doggerland. Doggerland was a landmass that connected what is now Britain to mainland Europe. During the last ice age, when sea levels were low, it wasn't just a narrow land bridge, it was a country. About 200,000 square kilometers, roughly the size of Great Britain itself. And it was prime real estate. We know this because of an unlikely source: oil companies. When energy companies started doing seismic surveys of the North Sea floor in the 1990s looking for oil and gas deposits, they were essentially creating underground maps of the sediment layers. And what they found was astonishing. Buried beneath the mud and sand of the seabed were ancient riverbeds, like basins, hills, and valleys. An entire landscape, perfectly preserved, frozen in time from when it was above water. Researchers analyzed these seismic images and reconstructed what Doggerland looked like. It had a huge river system, the Schotten River, that drained much of northern Europe and flowed through Doggerland into the Atlantic. There were wetlands, forests, and grasslands. The environment was rich and diverse. Pollen samples extracted from sediment cores show oak, hazel, and pine forests. Animal bones dredged up by fishing trawlers include aurochs, deer, and even mammoths with cut marks on them, evidence of human hunting. And there were people there, lots of people. Over the years, North Sea fishermen have accidentally hauled up thousands of prehistoric artifacts in their nets. Stone tools, carved bones, antler harpoons. In 1931, a fishing trawler pulled up a lump of peat, and when it was examined, archaeologists found a beautifully crafted barbed bone point, about 13,000 years old. This wasn't random garbage that drifted out to sea. This was in situ. It came from where people had been living. In 2019, divers discovered a Mesolithic settlement site off the coast near the Netherlands. They found flint tools, worked wood, and traces of what might have been structures. The site was dated to around 9,500 years ago, right when Doggerland was in its final centuries before being swallowed by the sea. Based on the environmental data and comparisons with similar landscapes, researchers estimate that at its peak, Doggerland could have supported tens of thousands of people, maybe more. These weren't just nomads passing through. This was home. They lived there for millennia. They developed culture, tools, knowledge about the land and sea. They probably had seasonal gathering sites, trade networks with neighboring regions, oral traditions passed down through generations. And then the water came. The final blow came around 6,200 BCE. That's when the Storegga slide happened, a massive underwater landslide off the coast of Norway. It triggered a tsunami that would have been catastrophic for anyone living in Doggerland or along the coasts of Britain and Scandinavia. Wave heights of 3 to 6 meters swept across the landscape. Within hours, low-lying areas would have been inundated. Anyone who survived would have found their world permanently changed. The sea didn't recede. It stayed, and it kept rising. By 6,000 years ago, Doggerland was gone, completely submerged. Britain became an island, and an entire chapter of human history vanished beneath the waves. Now here's the thing, Doggerland isn't unique. The same story played out all over the world. In Southeast Asia, there was Sundaland. During the Ice Age, the islands of Borneo, Java, Sumatra, and the Malay Peninsula were connected into a single landmass. We're talking about an area of roughly 1.8 million square kilometers, about twice the size of Texas. And unlike the cold northern landscapes, Sundaland was tropical, warm, fertile. It had rivers, rainforests, abundant wildlife. Stephen Oppenheimer, a geneticist and archaeologist, spent years studying this region. He argues that Sundaland wasn't just inhabited, it was a cultural core. He believes this region might have been where certain agricultural practices first developed, where maritime navigation was perfected, where some of the cultural traits we later see in Polynesian societies originated. Genetic evidence shows population dispersals from this region moving outward into the Pacific and northward into mainland Asia. But Sundaland is now underwater. The Java Sea, the Karamata Strait, the Gulf of Thailand, these are all drowned landscapes. We've barely explored them. There are a few cores, some bathymetric surveys, but systematic underwater archaeology, almost none. What's down there we don't know, but the potential is staggering. In the Persian Gulf, there's a similar story. During the Ice Age, the Gulf was mostly dry land. The Tigris and Euphrates rivers flowed down through a lush valley all the way to the Indian Ocean. This valley, known as the Gulf Oasis, would have been incredibly attractive for settlement, fresh water, fertile soil, fish, and game. It's been proposed that this region might have been the Eden referenced in ancient Middle Eastern mythology, a paradise lost to flooding. Archaeological sites in southern Mesopotamia show that some of the earliest evidence of permanent settlements and irrigation agriculture appear around 6,000 to 7,000 years ago. But these settlements are already sophisticated by the time we see them. Where did the people come from? Where did they develop these skills? One answer: they developed them in the lowlands of the Gulf before those lands flooded. When the water rose, they moved to higher ground and started over. What looks to us like the sudden appearance of civilization might actually be a migration and rebuilding process. The Black Sea has its own version of this story. There's a hypothesis proposed by geologists William Ryan and Walter Pittman that around 5,600 BCE, the Mediterranean Sea broke through the Bosphorus Strait and catastrophically flooded the Black Sea basin, which had been a much smaller freshwater lake. The flood would have raised the Black Sea level by tens of meters over a short period, months to years. Recent research suggests the flooding was more gradual than Ryan and Pittman initially proposed, but there's no doubt the Black Sea grew significantly, and coastal settlements were inundated. Underwater archaeological surveys have found submerged habitation sites near places like Sinop on the Turkish coast, perfectly preserved in the anaerobic mud. And then there's India. In 2001, the National Institute of Ocean Technology in India was conducting a survey in the Gulf of Cambay, also called the Gulf of Cambay, off the coast of Gujarat. They were using side-scan sonar to map the seabed, and they found something strange: geometric patterns, rectilinear structures, shapes that looked like walls and foundations. They went back and did more surveys. They dredged up samples, pottery fragments, semi-precious stones, fossilized wood. Some of the organic material was radiocarbon dated to around 7,500 BCE. If the structures are what they appear to be, and that's a big if, because controversy surrounds this site, then there's a drowned city in the Gulf of Cambay that predates the Indus Valley civilization by thousands of years. Most archaeologists are skeptical. They argue the geometric patterns could be natural geological formations, and the artifacts could have been carried to the site by currents from elsewhere. The waters in the Gulf are extremely murky, with near-zero visibility, so divers haven't been able to properly examine the structures in situ. It remains one of the great unverified mysteries. But here's what's not in dispute. The continental shelves are full of potential archaeological sites. We know people lived on them. We have the artifacts to prove it, and we've looked at almost none of it. In 2019, divers discovered a Mesolithic settlement site off the coast near the Netherlands. They found flint tools, worked wood, and traces of what might have been structures. The site was dated to around 9,500 years ago, right when Doggerland was in its final centuries before being swallowed by the sea. Based on the environmental data and comparisons with similar landscapes, researchers estimate that at its peak, Doggerland could have supported tens of thousands of people, maybe more. These weren't just nomads passing through. This was home. They lived there for millennia. They developed culture, tools, knowledge about the land and sea. They probably had seasonal gathering sites, trade networks with neighboring regions, oral traditions passed down through generations. And then the water came. The final blow came around 6,200 BCE. That's when the Storegga slide happened, a massive underwater landslide off the coast of Norway. It triggered a tsunami that would have been catastrophic for anyone living in Doggerland or along the coasts of Britain and Scandinavia. Wave heights of 3 to 6 meters swept across the landscape. Within hours, low-lying areas would have been inundated. Anyone who survived would have found their world permanently changed. The sea didn't recede. It stayed, and it kept rising. By 6,000 years ago, Doggerland was gone, completely submerged. Britain became an island, and an entire chapter of human history vanished beneath the waves. Now here's the thing, Doggerland isn't unique. The same story played out all over the world. In Southeast Asia, there was Sundaland. During the Ice Age, the islands of Borneo, Java, Sumatra, and the Malay Peninsula were connected into a single landmass. We're talking about an area of roughly 1.8 million square kilometers, about twice the size of Texas. And unlike the cold northern landscapes, Sundaland was tropical, warm, fertile. It had rivers, rainforests, abundant wildlife. Stephen Oppenheimer, a geneticist and archaeologist, spent years studying this region. He argues that Sundaland wasn't just inhabited, it was a cultural core. He believes this region might have been where certain agricultural practices first developed, where maritime navigation was perfected, where some of the cultural traits we later see in Polynesian societies originated. Genetic evidence shows population dispersals from this region moving outward into the Pacific and northward into mainland Asia. But Sundaland is now underwater. The Java Sea, the Karamata Strait, the Gulf of Thailand, these are all drowned landscapes. We've barely explored them. There are a few cores, some bathymetric surveys, but systematic underwater archaeology, almost none. What's down there we don't know, but the potential is staggering. In the Persian Gulf, there's a similar story. During the Ice Age, the Gulf was mostly dry land. The Tigris and Euphrates rivers flowed down through a lush valley all the way to the Indian Ocean. This valley, known as the Gulf Oasis, would have been incredibly attractive for settlement, fresh water, fertile soil, fish, and game. It's been proposed that this region might have been the Eden referenced in ancient Middle Eastern mythology, a paradise lost to flooding. Archaeological sites in southern Mesopotamia show that some of the earliest evidence of permanent settlements and irrigation agriculture appear around 6,000 to 7,000 years ago. But these settlements are already sophisticated by the time we see them. Where did the people come from? Where did they develop these skills? One answer: they developed them in the lowlands of the Gulf before those lands flooded. When the water rose, they moved to higher ground and started over. What looks to us like the sudden appearance of civilization might actually be a migration and rebuilding process. The Black Sea has its own version of this story. There's a hypothesis proposed by geologists William Ryan and Walter Pittman that around 5,600 BCE, the Mediterranean Sea broke through the Bosphorus Strait and catastrophically flooded the Black Sea basin, which had been a much smaller freshwater lake. The flood would have raised the Black Sea level by tens of meters over a short period, months to years. Recent research suggests the flooding was more gradual than Ryan and Pittman initially proposed, but there's no doubt the Black Sea grew significantly, and coastal settlements were inundated. Underwater archaeological surveys have found submerged habitation sites near places like Sinop on the Turkish coast, perfectly preserved in the anaerobic mud. And then there's India. In 2001, the National Institute of Ocean Technology in India was conducting a survey in the Gulf of Cambet, also called the Gulf of Cambay, off the coast of Gujarat. They were using side-scan sonar to map the seabed, and they found something strange: geometric patterns, rectilinear structures, shapes that looked like walls and foundations. They went back and did more surveys. They dredged up samples, pottery fragments, semi-precious stones, fossilized wood. Some of the organic material was radiocarbon dated to around 7,500 BCE. If the structures are what they appear to be, and that's a big if, because controversy surrounds this site, then there's a drowned city in the Gulf of Cambet that predates the Indus Valley civilization by thousands of years. Most archaeologists are skeptical. They argue the geometric patterns could be natural geological formations, and the artifacts could have been carried to the site by currents from elsewhere. The waters in the Gulf are extremely murky, with near-zero visibility, so divers haven't been able to properly examine the structures in situ. It remains one of the great unverified mysteries. But here's what's not in dispute. The continental shelves are full of potential archaeological sites. We know people lived on them. We have the artifacts to prove it, and we've looked at almost none of it. The MO and UMNTS in the desert. Okay, so we've established that massive amounts of land are underwater, and there are probably all kinds of sites we've never found. But what about the sites we have found? The ones on dry land that don't fit the standard timeline? Let me tell you about Nabta Playa. Nabta Playa is located in the Nubian desert of southern Egypt, one of the most inhospitable places on Earth today. It's barren, scorched, lifeless, but it wasn't always like that. Between roughly 11,000 and 5,000 years ago, during a period called the African Humid Period, the Sahara wasn't a desert. It was a savanna. There were lakes, rivers, grasslands. Hippos lived there. People lived there. At Nabta Playa, archaeologists found stone circles, alignments, and what appear to be ceremonial structures. The site was occupied seasonally by pastoralists, people who herded cattle, and they built these megalithic alignments with careful precision. Here's what's incredible. The stones are aligned to the summer solstice sunrise. On the day of the solstice, the sun rises directly along one of the stone lines. The site also appears to track certain stars, possibly Sirius, Arcturus, and stars in the constellation Orion. Researchers like Fred Wendorf and Kim Malville have argued that Nabta Playa represents some of the earliest evidence of astronomical observation and ceremonial alignment in Africa. The oldest parts of the site date to around 7,500 to 7,000 years ago. That's before the pyramids, before hieroglyphics. These were cattle herders living in the desert, and they had deep knowledge of the sky. They were tracking celestial cycles. They were encoding that knowledge in stone. When the climate shifted and the Sahara dried out around 5,000 years ago, the people at Nabta Playa had to leave. Where did they go? The hypothesis is that they migrated to the Nile Valley, and they brought their astronomical knowledge, their ritual practices, their cosmology with them. Some researchers believe the religion and astronomy of Pharaonic Egypt has roots in these much older desert cultures. And then there's Göbekli Tepe, which we talked about earlier. But there's more to this site than just its age. There's a particular pillar, Pillar 43, sometimes called the Vulture Stone, that sparked huge debates. On this pillar there are carvings of animals, a scorpion at the bottom, a bird that looks like a vulture or crane in the middle, and above it, a circular disc. Some researchers, particularly a scientist named Martin Sweatman, have analyzed the positions and arrangements of these animals and argued that they represent constellations. Specifically, he claims the pillar is depicting the night sky as it would have appeared around 10,950 BCE, right around the time of the Younger Dryas comet impact. The disk, he argues, represents the sun. The arrangement of animals matches the positions of stars. The scorpion is Scorpius. The bird is Cygnus, or another constellation. If true, this would mean Göbekli Tepe wasn't just a temple. It was a memorial, a record carved in stone to remember a cosmic catastrophe. Now, the excavators at Göbekli Tepe, particularly the late Klaus Schmidt and his successors, have pushed back against this interpretation. They argue that the animals depicted on the pillars correspond to actual animals found in the archaeological record at the site, bones of gazelles, foxes, aurochs. They think the carvings are totemic or symbolic representations of the local environment and mythology, not a star map. They also point out that the pillars were often moved and reused, so using their final positions to determine astronomical alignments is unreliable. So who's right? We don't know for sure. What we can say is that the people who built Göbekli Tepe were far more sophisticated than we ever imagined. Whether or not they were encoding astronomical data, they were creating complex symbolic art, organizing large labor forces, and constructing something meant to last for generations. And Göbekli Tepe isn't alone. In the same region of southeastern Turkey, archaeologists have found other sites with similar architecture. Karahan Tepe, Harbitsuvan Tepesi, Seyfa Tepe, these are part of what researchers now call the Tash Tepeler, the Stone Hills. They all date to roughly the same period, and they all feature T-shaped pillars and megalithic construction. This wasn't an isolated phenomenon. It was a regional tradition. What it tells us is that 11,000 years ago, there was already a culture in the Near East capable of monumental construction, symbolic expression, and social organization on a scale that wasn't supposed to exist until thousands of years later. The knowledge that was lost. So let's think about what we've learned so far. We have evidence of complex societies building monuments before agriculture. We have massive coastal landscapes that are now underwater, where people lived for millennia. And we have a period of catastrophic climate change, the Younger Dryas, that would have devastated these populations. What happens to a society when it's hit by a disaster like that? Let me tell you what doesn't happen. The knowledge doesn't magically survive. There's no backup drive, no library, no internet. In a pre-literate society, knowledge is stored in people's heads. It's passed down through oral tradition, through apprenticeships, through rituals and ceremonies, and it's fragile. Imagine you're part of a community that has deep astronomical knowledge. You've spent generations observing the stars, tracking the seasons, building stone monuments aligned to celestial events. You have elders who remember the old ways, who teach the young people how to read the sky, how to predict the solstices, how to time your planting and harvesting. Then the disaster hits. Maybe it's the Younger Dryas impact. Maybe it's flooding from rapid sea level rise. Maybe it's both. Your community is scattered, people flee. The elders die before they can pass on all their knowledge. The young people are focused on survival, finding food, finding shelter, not on learning abstract star lore. A generation passes. The stories become fragmented, half-remembered. Another generation and their myths. This is what we call a knowledge bottleneck, and it doesn't require everyone to die. It just requires the chain of transmission to break. There's a concept in archaeology called the Neolithic Revolution, which describes the transition from hunting and gathering to agriculture and settled life. For a long time, this was viewed as a sudden leap forward. Humans figured out farming, and everything else followed. But the more we dig, the more we realize it wasn't sudden at all. It was messy, gradual, and filled with false starts. In the Levant, there's evidence that people were experimenting with plant cultivation long before they became fully agricultural. Sites like Ohalo II in Israel, dated to around 23,000 years ago, show use of wild grains. People were harvesting them, processing them, maybe even protecting and managing the stands. But they weren't farming. Not yet. Then the Younger Dryas hits and the climate becomes unstable. Wild grain stands shrink. Resources become scarce. And at some point, people start deliberately planting seeds, irrigating, selectively breeding plants. Agriculture emerges not as an invention, but as a survival strategy forced by environmental stress. And here's the thing, this might not have been the first time someone tried it. We might be looking at the successful iteration, the version that stuck because it happened during the right climate window. Earlier attempts, in earlier periods, might have existed and then failed or been abandoned when conditions changed. Holocene, the period we're in now, the last 11,700 years, is the most stable climate period in over 100,000 years. Before the Holocene, the climate was wildly variable. The last ice age wasn't a smooth, steady, cold period. It was chaotic. Temperature swings, droughts, floods. Trying to build a complex, sedentary society in that environment would be like trying to build a house on a boat in a storm. It's possible, but it's hard, and it probably won't last. The Holocene gave us stability, and with stability, we got agriculture, cities, writing, civilization as we know it. But the capacity, the cognitive ability, the social structures, the accumulated knowledge that didn't suddenly appear 10,000 years ago, it was there before. It just couldn't flourish. The continental shelf, where the answers are. So here's where we are. We know that humans were more complex than we thought, earlier than we thought. We know that massive amounts of land, prime settlement land, are now underwater. We know that climate catastrophes wiped out populations and disrupted cultures. And we know that knowledge can be lost. The question is, What do we do with this information? How do we test it? How do we find out what's really down there on the continental shelves? The short answer is marine archaeology, but it's not easy. Underwater archaeology is expensive, technically challenging, and time-consuming. On land, you can use ground-penetrating radar, satellite imagery, LiDAR to scan huge areas quickly and cheaply. You can dig test pits, run surveys. Underwater, visibility is often terrible. Currents are strong. You need specialized equipment, research vessels, remotely operated vehicles, divers trained in archaeological methods. A single research cruise can cost millions of dollars. But it can be done. And when it's done right, the results are extraordinary. In Australia, a team of researchers developed a strategy for finding submerged archaeological sites on the continental shelf off the northwest coast. They used predictive modeling essentially. They looked at where people would have lived based on the landscape, near rivers, near coastlines, in areas with good resources. Then they used bathymetric data to identify where those features would be underwater today. They targeted those areas with underwater surveys. And they found artifacts, stone tools in situ, sitting on ancient land surfaces now 20 meters below sea level. These weren't tools that had washed out to sea. They were where people had dropped them thousands of years ago, before the ocean covered the land. This proves something important. The sites are there, and they can be preserved. If we look in the right places with the right methods, we can find them. The Doggerland surveys used 3D seismic data originally collected by oil companies. Researchers reanalyzed this data for archaeological purposes. They identified paleo-river channels, ancient lake beds, areas that would have been attractive for settlement. Some of these features show acoustic anomalies that could be cultural, maybe shell middens, maybe human-made structures. We won't know until someone goes down there and looks. In the Mediterranean, underwater archaeologists have found entire ancient ports and cities. Pavloptri in Greece, Heracleion in Egypt, these are much later, from classical antiquity, but they demonstrate that underwater archaeology is possible even in complex environments. The technology keeps getting better. Autonomous underwater vehicles can now survey large areas with high-resolution sonar. Sub-bottom profilers can see through sediment layers to identify buried structures. ROVs equipped with cameras can inspect features in detail without needing human divers. What we need is funding, organization, and political will. We need governments and institutions to prioritize this research. We need international collaboration because these drowned landscapes cross modern national boundaries. Doggerland spans British, Dutch, German, and Danish waters. Sunderland involves Indonesia, Malaysia, Thailand, Vietnam. The Gulf sites involve multiple Middle Eastern nations. And we need to move quickly because time is not on our side. The ocean is rising again due to modern climate change. Storm surges, coastal erosion, and human activities like trawling and dredging are actively destroying these sites. Every year we wait, we lose more evidence. The alternative, explations. Now I want to pause here and address something. Because whenever you talk about lost civilizations or underwater archaeology, there's a certain crowd that shows up claiming this proves Atlantis was real, or that ancient aliens taught humans how to build pyramids, or some other wild theory. And I need to be very clear, that's not what the evidence shows. The evidence shows that humans were capable of complexity earlier than we thought. It shows that a lot of the human story is literally underwater and unstudied. It shows that climate catastrophes disrupted human societies and potentially caused knowledge loss. What it does not show is that there was some advanced, globe-spanning supercivilization with technology beyond what we have today. There's no evidence for that, at all. When people talk about ancient high technology, they usually point to things like the precision of Egyptian stonework or the size of the stones at Baalbek in Lebanon. And yes, some of this work is incredibly impressive. The granite boxes in the Serapeum of Saqqara are carved with remarkable precision. The trilithon blocks at Baalbek weigh 800 tons each. But here's the thing. We know how this was done. We have experimental archaeology that shows ancient techniques could achieve these results. Denys Stocks, an archaeologist who specialized in ancient Egyptian technology, spent decades replicating Egyptian stoneworking methods. He showed that copper tools, quartz sand abrasive, and a lot of patient labor could drill through granite, saw through limestone, and achieve the precision we see in ancient monuments. The marks on ancient cores and saw cuts aren't from lasers or power tools. They're from hand tools. Scanning electron microscopy of the tool marks shows patterns consistent with abrasive cutting random scratch marks from sand grains, not the uniform striations you'd get from a machine. The massive stones. We have historical records and engineering studies showing how they were moved. The Romans moved the Baalbek trilithon using wooden rollers, levers, capstans, and massive amounts of coordinated labor. It's at the extreme limit of what pre-industrial technology could do, but it's within the limits. There's no need to invoke lost ancient super technology. Same with claims about ancient maps supposedly showing Antarctica without ice. The Piri Reis map, often cited, is from 1513 and is based on earlier Ptolemaic maps and contemporary Portuguese charts. The coastline that people claim shows Antarctica is actually the coast of South America, distorted because the mapmaker was working with incomplete information and trying to fit the geography onto a piece of parchment. Antarctica has been covered in ice for 15 million years. Ice core data confirms this. There was no ice-free window when ancient sailors could have mapped it. So no, we're not looking for Atlantis with laser weapons and flying machines. What we're looking for is something more interesting. Complex societies of hunter-gatherers and early horticulturalists who built monuments, tracked the stars, created art, traded over long distances, and had rich cultural lives that were disrupted by climate change and sea level rise. These societies existed at a time when the climate was unstable. They didn't have writing, so they couldn't leave permanent records. They probably built mostly with wood, earth, and biodegradable materials, which don't survive well in the archaeological record. And they lived on coastlines that are now underwater. What we're talking about isn't a fantasy. It's just history, real human history, and it's more interesting than any made-up story. The pattern of collapse and renewal. There's a bigger pattern here that I want you to see. Because when you step back and look at the full scope of human history, something becomes clear. We keep trying, and we keep getting reset. Göbekli Tepe was built around 9600 BCE. It was used for about 1,500 years, and then it was deliberately buried. The people who used it filled in the enclosures with rubble and dirt, carefully covering the pillars. Why? We don't know. Maybe the belief system changed. Maybe the population moved. Maybe resources became scarce and they couldn't maintain it anymore. But after Göbekli Tepe was buried, the practice of building these megalithic ceremonial centers in that region seems to have stopped. The tradition ended, and it took thousands of years before monumental architecture appeared again in the Near East. In Europe, there's a similar pattern. Megalithic construction, stone circles, dolmens, passage tombs appeared in many places during the Neolithic. Stonehenge, Newgrange, the Carnac stones in France. These represent enormous investments of labor and sophisticated understanding of astronomy and engineering. And then in many regions, the tradition stopped. The knowledge faded. In the Americas, we see repeated cycles of rise and fall. The Olmec, the Maya, Teotihuacan, the Mississippian mound builders, all of them reached impressive levels of complexity, and all of them experienced collapse or transformation. Often the collapses correspond with climate shifts, droughts, floods, volcanic eruptions. The point is, complexity is fragile. It requires specific conditions to develop and specific conditions to sustain. When those conditions disappear, when the climate destabilizes, when resources fail, when populations are disrupted, complexity can vanish remarkably fast. And this is why the Younger Dryas matters so much. If there were societies in the late Pleistocene that had achieved significant complexity monument building, astronomical knowledge, long-distance trade, the Younger Dryas would have been a reset button. A hard reset. Imagine you're part of a society that has been stable for 1,000 years. You have seasonal gathering sites, trade networks, specialists who carve stone and track the stars. Then the temperature drops, the megafauna die, the plants you depend on wither. You can't stay where you are. You have to move. But where? Everyone else is moving too, competing for dwindling resources. Social structures break down. The specialists, the astronomers, the master builders, they can't do their work anymore because everyone is focused on immediate survival. The gathering sites are abandoned. The oral traditions, passed from master to apprentice, are interrupted. A generation dies without passing on their full knowledge. By the time stability returns, you're starting over. You remember fragments, myths about a time before, stories about ancestors who built great things, but the specific knowledge, how to construct the monuments, how to read the stars, that's gone. You have to rediscover it. And maybe you do. Maybe over centuries, your descendants figure it out again, rebuild, reach new heights. Or maybe you don't. Maybe you stay at a simpler level of organization because the environment doesn't allow for more. This is the contingent nature of civilization. We're not guaranteed to progress. We're not on a smooth upward trajectory. We're constantly at the mercy of our environment, our resources, our climate. And we're lucky. The Holocene has been unusually stable. For 11,000 years, the climate has been relatively predictable. That's given us the breathing room to develop agriculture, cities, writing, technology. But it's not guaranteed to last. And it's not the first time humans have tried to build complexity. It's just the first time we've succeeded and sustained it this long. The ONES who remember. There's something haunting about flood myths. Every culture on Earth seems to have one. The story of Noah's Ark in the Bible. The Epic of Gilgamesh from Mesopotamia, which has a nearly identical flood story that predates Noah by over 1,000 years. Hindu texts describe a great flood. Greek mythology has Deucalion's flood. In Chinese mythology, there's the Great Flood of Gun-Yu. Indigenous Australian stories tell of the sea rising and drowning the land. Polynesian myths speak of inundations. Native American tribes have flood stories. For a long time, scholars dismissed these as independent inventions, cultures trying to explain natural disasters like local floods or tsunamis. But there's another possibility. What if they're memories? Not literal, word-for-word historical accounts. Oral traditions don't work that way. They change and evolve over time, incorporating symbolic elements, moral lessons, supernatural beings. But the core of the story, the kernel of truth, can persist for thousands of years. We know this because we've tested it. In Australia, Aboriginal oral traditions describe coastal landscapes and features that are now underwater. They talk about places where people used to hunt, islands that used to be accessible on foot. Researchers have compared these stories to geological data, and they match. The stories are describing geography from when sea levels were lower, potentially 7,000 to 10,000 years ago. Think about that. 10,000 years of oral tradition, passed from generation to generation, describing a world that no living person has seen. And it's accurate. So when cultures all over the world tell stories of a great flood that destroyed the world, is it really surprising? Between 15,000 and 6,000 years ago, the world did flood. Coastlines that had been stable for tens of thousands of years were inundated. Islands disappeared. River valleys became seas. Entire landscapes were erased. People who lived through this, who saw the water rising year after year, who had to abandon their homes, who lost their sacred sites and gathering places to the ocean, they would tell their children. And their children would tell their children. The story would change, become mythologized, but the memory would persist. The flood was real. The question is, what else was real that we've forgotten? the research that needs to happen. All right, let's talk about what comes next, because this isn't just an intellectual puzzle. If we want to know whether there were complex societies on the continental shelves, whether they were disrupted by climate catastrophe, whether knowledge was lost, we can test it. We can find out, but we need a plan. Here's what that plan looks like. First, we need comprehensive mapping. We have bathymetric data for most of the ocean floor now, but it's low resolution. For archaeological purposes, we need high-resolution multi-beam sonar surveys of the continental shelves, focusing on areas that would have been attractive for settlement. Paleoriver valleys, ancient coastlines, estuaries, areas with good resources. Second, we need cores. Lots and lots of cores. Sediment cores from the seabed can tell us about the environment, what plants grew there, what animals lived there, whether there's charcoal indicating fire use, whether there are pollen signatures suggesting human impact on vegetation. Cores can also give us chronology through radiocarbon dating of organic material. Third, we need targeted surveys using remotely operated vehicles and autonomous underwater vehicles to visually inspect areas of high potential. We're looking for anomalies, features that don't fit natural geological processes. Shell middens, stone alignments, post holes, worked wood, anything that indicates human activity. Fourth, where we find promising sites, we need excavation, real archaeology, conducted by trained archaeologists using proper methodology. Not treasure hunters, not amateurs, but scientists who can record context, analyze stratigraphy, extract and preserve fragile materials. Fifth, we need dating programs. Radiocarbon dating of any organic materials. Optically stimulated luminescence dating for sediments and stone. Uranium-thorium dating for calcite formations. We need multiple, independent dates from multiple materials to build robust chronologies. Sixth, and this is crucial, we need open data. Everything should be published in peer-reviewed journals, with all raw data made publicly available so other scientists can verify and build on the findings. No secret discoveries, no withholding evidence, no sensational claims without substantiation. This is expensive. A single research expedition could cost $1 million or more. A comprehensive program covering multiple regions would cost tens or hundreds of millions. That's a lot of money, but consider what we're talking about. We're talking about potentially rewriting the entire story of human civilization. We're talking about finding lost chapters of our history. That's worth funding. And it's not just about satisfying curiosity. Understanding how past societies responded to climate change, how they adapted or failed to adapt, what happens when knowledge is lost. This has direct relevance to our current situation. We're in a period of rapid climate change right now. We're facing environmental challenges that will test our societies. Looking at how humans dealt with similar challenges in the past could provide valuable lessons. There are organizations working on this. The Maritime Archaeology Trust, the Institute of Nautical Archaeology, various university programs around the world. But they're underfunded and understaffed. Governments spend billions on space exploration, which is wonderful, but we've barely scratched the surface of exploring our own planet's submerged landscapes. We need a global initiative, an international coalition dedicated to continental shelf archaeology, something on the scale of the Human Genome Project or the Large Hadron Collider. Because this isn't just one nation's history. This is human history. It belongs to all of us. The testable hypotheses. Let me give you some specific testable hypotheses that emerge from all of this. Because science progresses through testing predictions. If an idea is true, what evidence would we expect to find? And crucially, what evidence would prove it wrong? Hypothesis 1. The density of late Pleistocene and early Holocene archaeological sites on now submerged continental shelves is equal to or greater than the density of contemporaneous sites in inland areas. This predicts that systematic surveys of areas like Doggerland, Sunderland, and the northwest Australian shelf will yield numerous sites. If we survey these areas thoroughly and find nothing, the hypothesis is falsified. Hypothesis 2. At least one submerged site will show evidence of monumental construction, organized labor, or technological sophistication comparable to or exceeding sites like Göbekli Tepe. This would indicate that coastal populations had achieved similar or higher levels of complexity. If all submerged sites show only simple hunter-gatherer camps with no signs of organization beyond small groups, this hypothesis is falsified. Hypothesis 3. Sediment cores from the younger Dryas boundary layer in coastal and near-coastal settings will show abrupt changes in human activity markers, decreased charcoal, changes in pollen indicating abandonment of managed landscapes, interruptions in sediment accumulation at occupied sites. This would support the idea of population disruption. If sediment cores show continuity across the younger Dryas boundary, it would suggest populations weathered the event without major disruption. Hypothesis 4. Analysis of ancient DNA from human remains and archaeological contexts will show population bottlenecks and migrations corresponding to the younger Dryas period and subsequent sea level rise. If genetic data shows smooth continuity with no bottlenecks, it would challenge the catastrophe narrative. Hypothesis 5. Stone monuments like Göbekli Tepe and Nabta Playa encode astronomical information through their alignments that is statistically significant beyond chance. This can be tested through rigorous statistical analysis, comparing the alignments to simulated random alignments. If the alignments are no more significant than random chance, astronomical encoding is not supported. Hypothesis 6. Oral traditions describing drowned landscapes can be correlated with specific geological features and dated using the geological record. If traditional stories consistently describe features that match underwater topography dated to specific time periods, it supports long-term cultural memory. If stories don't correlate with any identifiable features, it suggests the stories are purely mythological. These are falsifiable. That's important. A hypothesis that can't be proven wrong isn't science, it's just speculation. What we're proposing here can be tested, and it should be. What it means for us. So what does all of this mean? Why does it matter if there were complex societies 12,000 years ago that we didn't know about? It matters because it changes how we think about ourselves. For most of modern history, Western civilization has told itself a story of progress, that we're the pinnacle of human achievement, that we've advanced beyond all previous cultures, that history is a march upward from primitive to civilized. And implicit in that story is the idea that we're secure, that we've reached a level of technology and knowledge that makes us invulnerable. But the evidence we've been looking at tells a different story. It tells us that complexity is contingent, that civilizations can rise and fall, that knowledge can be lost, that we are not immune to the forces of nature. The people who built Göbekli Tepe were every bit as intelligent as we are. They were creative, capable, organized, and yet their societies didn't survive in a form we can recognize. The knowledge they had how to build those monuments, what the symbols meant, what their cosmology was, it's mostly gone. We can study the ruins, but we can't talk to them. We can't ask them what they were thinking. The people who lived in Doggerland, who fished those rivers and hunted those forests for thousands of years, they're voiceless. Their entire world is underwater. We don't know their stories. We don't know what they achieved. We don't know what they knew. And the sobering part is, the same thing could happen to us. Not in the same way, not for the same reasons, but the principle holds. We are not guaranteed to continue. Our civilization, for all its technology, is built on a foundation of environmental stability that we're actively destabilizing. We rely on systems, agriculture, trade, infrastructure that are vulnerable to disruption. If something happened, a major volcanic eruption, a significant asteroid impact, runaway climate change, nuclear war, and our civilization collapsed, what would survive of us? Most of our knowledge is digital now. Digital storage requires power, maintenance, compatible reading technology. In a collapse scenario, that's gone fast. Books last longer, but paper degrades. Stone lasts longest, but we don't write on stone anymore. What would archaeologists 10,000 years from now think of us if they only found our ruins? Would they understand what the internet was? Would they know we'd mapped the human genome, sent probes to the edge of the solar system, split the atom? Or would they just see the buildings and have no context? This isn't meant to be depressing. It's meant to be humbling. We are part of a long story of humans trying to make sense of the world, trying to build something lasting, trying to understand our place in the cosmos. And we're not the first chapter. We're probably not even the second or third. We're the latest iteration in a series of attempts. And that's okay. In fact, it's beautiful, because it means we're connected to those people in Doggerland, the builders of Göbekli Tepe, the astronomers of Nabta Playa. They were doing what we're doing, trying, building, learning, hopping it lasts. The memory we carry. I want to end by coming back to where we started, the drowned lands. Because there's something profound about standing on a coastline and knowing that just a few kilometers out, beneath the waves, there are landscapes that people once called home. In 2019, a team of archaeologists was working off the coast of England, surveying the seabed. They found a Mesolithic site, tools, worked wood, evidence of occupation. And while they were documenting it, one of the divers found something small, a piece of worked flint about the size of a thumbnail. Under a microscope, they could see the manufacturing marks, the way someone had carefully knapped it to a precise shape. It was a microlith, probably part of a composite tool. And as the archaeologist held it, she realized the last person to touch this object before her was someone who lived 9,000 years ago. Someone who stood on that land when it was dry, who made this tool, who dropped it, who moved on with their day never knowing that their world would one day be at the bottom of the sea. That moment of connection across time, that's what this is about. Not proving theories or winning arguments. It's about remembering that the people we're talking about were real. They loved, they learned, they created, they suffered, they hoped. They were us. And their story is our story, because we're still here. We survived. Through ice ages and floods and volcanic winters and plagues and all the countless disasters that nature and history have thrown at us, some thread of humanity persisted. The knowledge was lost and rediscovered. The monuments fell and were rebuilt. The coastlines drowned and we moved to higher ground. We are the inheritors of all of that. Every language we speak, every tool we use, every story we tell carries echoes of those earlier attempts. We stand on the shoulders of people whose names we'll never know, who lived in places we'll never see, who solved problems we'll never face. And maybe, thousands of years from now, someone will stand where we stood and wonder about us. What we knew, what we built, what we hoped for. And if we're lucky, if we do this right, maybe they'll find more than ruins. Maybe they'll find our knowledge preserved, our stories told, our understanding passed on. Because that's what this is really about. Not lost civilizations, not ancient mysteries. It's about the thread that connects all of us across time. The thread that says we were here, we tried, we learned, we passed it on. And as long as that thread holds, we're not lost, we're remembered. The ocean holds our past, the land holds our present, and the future, that's ours to shape. But we can't shape it wisely if we don't understand where we came from. We can't know where we're going if we don't know where we've been. So we dive, we dig, we ask questions, we test hypotheses, we search for the truth wherever it leads. Because those drowned cities, those buried monuments, those lost stories, they're not separate from us. They're us. Just earlier versions, earlier attempts. And this time, maybe we get it right. Maybe this time we build something that lasts. Maybe this time we remember. 27 million square kilometers, that's what's underwater. That's what we haven't searched. That's where the answers are. We've been writing the story of humanity with less than 1% of the evidence. We've been studying the refugees and calling them the pioneers. We've been looking at the survivors and forgetting about everyone who drowned. But the evidence is there. It's been there all along, under the North Sea, under the Java Sea, under the Persian Gulf, buried in sediment waiting. And every year we get better at finding it. Better sonar, better submersibles, better dating techniques, better models. The technology exists. The sites exist. The only question is whether we have the will to look. Because this isn't ancient history. This is human history. This is where we came from. And until we know the full story, until we've searched those continental shelves, mapped those drowned landscapes, found those lost settlements, we don't really know ourselves. We are not the first civilization. We're not even the first attempt. We're just the one that got lucky. The one that arose during the Holocene when the climate was stable enough to give us a chance. And what we do with that chance, whether we preserve it, whether we remember it, whether we pass it on, that's up to us. The ocean remembers, the sediment remembers, the stones remember. Now it's our turn. If this changed how you see history, there's more to explore. Hit subscribe.